Welcome to the Math Record. Today I'll be covering the ICTM Regional 2017 Division AA Algebra 1 questions 14, 19, and 20. As usual, I'll go through every 20. That's all 20. Now let's begin with 14. The number 1a, 2b, 6, where a and b are digits, is evenly divisible by 12. Determine the number of possible values for 1a, 2b, 6 could represent. So basically, we know it's divisible by 12. That means it must be divisible by 3 and 4 also, because that's making up 12. So the divisibility rule for 3 is that the sum of the digits has to be equal to multiple of 3. So 1 plus a plus 2 plus b plus 6 is equal to a multiple of 3. So I'll call that 3x. And it has to be divisible by 4 also. So the rule for this is that the last two digits have to be divisible by 4. Let's call that y. So let's look for values for b first and then values for a later, because this is easier. So using b6, if b is 0, that's 6. So 6 is not divisible by 4. If b is 1, that's 16. 16 is divisible by 4, so that works. If b is 2, that's 26, not divisible by 4. If b is 3, that's 36, that's divisible by 4. If b is 4, that's 46, that's not divisible by 4. If b is 5, that's 56, that's divisible by 4. And we see a pattern, 1, 3, 5, so next one's 7, and next one's 9. Okay, so now let's look at this rule now. So we know that 1 plus 2 plus 3 plus 6, that is 9. So that's already a multiple of 3. So that tells us that a plus b also has to be a multiple of 3 by itself. So it has to be a multiple of 3. So we know that b, if b is 1, then a could be 2, and then the next one's 5, and the next one's 8, because that'll be 3, 6, and 9. That's why you just add 3 to 2, add 3 to 5 to make 8, right? So it's pretty easy to write all the combinations. And then a, we know if this 3, that's a multiple of 3, so a has to be a multiple of 3, so that's 0, 3, 6, and 9. And if b is 5, then the next multiple of 3 is when it's 1, that makes 6. And then add 3, that's a 4, and then add 3, that's a 7. And when b is 7, the next one is 9, so that makes a 2, and that makes 9, and then a 5, and then an 8. And if b equals 9, then a equals 0, 3, 6, or 9. Okay, so how many possibilities are there? We'll just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there's 17 combinations, so that's your answer for number 14. Okay, now let's work on number 19. If a cubed plus b cubed equals 2000 and a squared b plus ab squared equals 400 and a squared plus b squared equals kab, determine the value for k. So we need to find this. So usually when I see something that's cubed, I like to put the terms together and then cube it. So a plus b cubed. So what would this factor out as? Well, that's a cubed plus 3a squared b plus 3ab squared plus b cubed. So we only need these two because that's what gives us our 2000. So we need to take away this number. So that gives us that a plus b cubed minus 3. And then we could factor out our 3 when we make a squared b plus ab squared is equal to our a cubed plus b cubed, which is 2000. So what is a squared b plus ab squared? Well, that's 400. They already gave us that. So we know ab cubed minus 3 times 400, which is 1200, and then add that to the other side. So that makes 1200 plus 2000, which is 3200. Okay, so we got this number. So what are we supposed to do with this? Well, if we kind of look at our second one, which is a squared b plus ab squared, we notice that we can factor out a and a b. So a and b factor out, and that will leave us an a plus a b inside, which will equals to our 400. So I notice that this and this are the same, and this one's cubed while this is squared. So what I would like to do is that I would like to separate this from a plus b cubed into a plus b squared times a plus b, and that equals to 3200. And I know that a plus b is equal to 400 divided by ab. So a plus b squared, 400 divided by ab is equal to 3,200. So I know that a plus b squared is equal to 3,200 divided by 400. So 32 divided by 4 is 8, and then you multiply ab. So I know that a plus b squared is equal to 8ab. But we're not looking for that. We're looking for a squared plus b squared, not a plus b squared. So how do we find that? Well, I know if we expand this out, this is a squared plus b squared plus 2ab equals 8ab. And now we can find a squared plus b squared. A squared plus b squared, 8ab minus 2ab is 6ab. So our value for k is equal to 6. And that is your answer for number 19. So you just had to rewrite your variables. Okay, number 20. A pair of standard six-sided die are rolled. Determine the probability of rolling either a number that's more than 4 on at least one die, or the sum that is more than a sum that's more than 4 on the face-up die. Okay, so let's say we have our first dice. The first numbers are 1, 2, 3, 4, 5, and 6. Okay, so what combinations does this work? Let's look at the first one. Such that a number that's more than 4 at least one of the die. Well, if the first number for a die is 1, that means the second die must be at least a 5 or a 6. If it's 2, that means there's also need to be a 5 or 6. If it's 3, it's either a 5 or 6. And if it's a 4, it has to be 5 or 6. But if 5, but if our first dice is a 5 or a 6, right, which are already more than 4 and is at least one of them, then basically the second dice could be whatever it wants to be. So it could be 1 through 6. And this gotta be 1 through 6. Okay, now let's look at the second possibility, or a sum that's more than 4. Well, if we look at this, um, this is more than 4. Obviously, all these numbers are more than 4. More than 4. So, so we know all that these work. So let's just find what other ones also work. So, what makes basically a 4? So, to get a sum of 4. Sum of 4. So to get a sum of 4, let's just say there's a 1 and a 3. That makes 4. What else can you do to get 4? Well, 2 and 2. That makes a sum of 4. And we could also try numbers that are like lower than 4, because then that is not this possibility. So then we could try 1, 1, which also works. 1, 2, that also works. 1, 3 is already accounted for, and then 1, 4 doesn't work. And then we have 2, 2, which works, and then 2, 3, which stops. So after that, we notice that only these combinations are the ones that are the sum of 4 or less than the sum of 4, basically, or less than it. So basically, this is all the possibilities that don't work. So that would be 1, 3, or 3 and 1, so there's 2 here. And 2, 2 is just one possibility. 1, 1 is one possibility. And 1, 2, or 2, 1, that's two possibility. So that's 2, 3, 4, 5, 6. So there's 6 possibilities that don't work. Possibilities that don't work. So if 6 don't work, how many possibilities are there in total? Well, there's 6 in the first dice and 6 in the next dice, so that's 36. So if 6 don't work, then 36 minus 6 are the ones that work, so that's 30. So 30 out of 36 will be our probability, which is 5/6. And that is our answer for number 20. So the probability for the first one doesn't even matter because it's already accounted for by the sum of 4. And that basically covers our ICTM Regional Division A 2017 Algebra 1. Thanks for watching, and I'll see you at the next math record. And here are the answers.